In 1999, humanity was on the verge of a major breakthrough. With the help of the Hubble Space Telescope, scientists found the most distant and possibly the largest galaxy ever. However, a bit later, there were certain adjustments to the research. It turned out that the astronomers had spotted not a galaxy, but a ray of light emitted by one star reflected off another and shining right at the telescope. This works like a sunbeam bouncing off a mirror, and oddly enough, such blunders happen in the scientific world with striking regularity. In this video, you'll figure out why NASA still hasn't kicked out certain scientists for cheating, how galaxies are born, and what objects in the universe are the largest, or at least we think they are. So, how do scientists determine the sizes of celestial bodies?
The universe told me.
Of course, the methodology is slightly different from what Neil deGrasse Tyson described here. Currently, it's believed that the biggest nebula in space is NGC 2070, also known as the Tarantula. But why can't we award it first prize just yet? There's another catch waiting for humankind. Typically, astronomers measure the distance between objects considering the speed of light. But the problem is, inside a nebula, it can be much lower than usual, and that's why it's almost impossible to determine the precise boundaries of this area. Perhaps at least stars will make the task easier. UY Scuti is an undoubted leader among them. Its radius is 1,708 times bigger than that of our Sun. It seems that we've got a winner here. But wait, what in the world is that? In 2020, Stephenson 218 was named the largest star known. It's as much as 2,158 times bigger than our Sun. But why had we never seen it before? Apparently, the reason for this is its luminosity. Although UY Scuti lost the diameter battle to Stephenson, it certainly stayed one of the brightest players out there. What's more, stars tend to pulsate, or in other words, periodically contract and expand while simultaneously changing their shapes. But if we can't determine the exact sizes of stars, what do we do with larger objects then? With black holes, for example? It might come as a surprise, but it's relatively easy to calculate the sizes of black holes. Their masses are measured based on gamma-ray emissions produced by a black hole while swallowing up other objects. It's too soon to celebrate, though. Before using these gamma rays for any sort of calculations, we've got to track them first, and this may take up to several decades. Right now, the title of the most giant black hole belongs to Ton 618. Its weight is 66 billion times greater than that of the Sun. It's hard to imagine a thing like this, right? But there are even more extensive objects in outer space. When black holes suck up everything they meet on the way, they form huge funnels that in turn form entire galaxies. IC 1101 is a supergiant elliptical galaxy. There are about 250 billion stars in the Milky Way. Well, in IC 1101 alone, there are 1,000 trillion of them. The galaxy lies 1.04 billion light-years away from Earth in the constellation of Virgo. Quite possibly, this is the most giant known galaxy. But can we really be sure if we still can't reach a general agreement on the size of our own Milky Way? The Hubble Space Telescope has helped unravel the secrets of the universe and establish that the speed of the Milky Way's expansion is much faster than what researchers relied on earlier. Perhaps the Milky Way isn't really so teeny tiny. as it turns out that it's been growing 10 times faster than previously thought. But does this mean that the other celestial body sizes could have also been calculated wrong? If so, why do we keep trusting scientists instead of kicking them out of NASA and calling them charlatans? Maybe, given all these errors, it's time we made not a list of the largest objects, but created a wall of shame featuring the most dishonest scientists. The main problem here is that all evidence is purely circumstantial in astronomy. There's no supreme authority that could confirm or deny all human suspicions. The gathered information comes together very slowly, like some extra difficult jigsaw puzzle. But then, how can we determine the largest object in the universe? And what if we need to look not for the object itself, but for its absence? Probably the most interesting things in space are not celestial bodies that form clusters, but vice versa. Voids, places that don't even contain matter. In 2004, scholars found the Eridanus supervoid. According to preliminary projections, it stretches across 1.8 billion light-years. A monster like that can easily claim the title of the largest object, but can a void be regarded as an object?
That's kind of freaky right there.
And if it can, how do we determine the size of the absent matter when there's a perfect vacuum? Not an easy task, is it? We still can't fully trust our data about outer space outside our Milky Way, and even inside it, things are not that plain and clear. However, maybe we'll finally be able to complete this jigsaw puzzle soon, and then every inch of our universe will be like an open book. Or the other way around, maybe we'll have to accept that we are even more helpless than we think we are.
You might think you understand, but do you really?
Which of these scenarios sounds more likely to you?